What up, my people? After watching this video, you will be able to define even and odd functions. Let's go.
Yeah.
Let's begin with some vocabulary. Even functions are functions where the output when x is equal to x is the same thing as the output when x is the opposite. So for example, if x was equal to 1, the output would be the same thing as if x is equal to -1. And that happens for all x's inside the domain of the function. Also, the graph is going to be symmetric to the y-axis. For odd functions, we have f of -x is equal to the negative f of x. So in this case, if we have the opposite x values, the outputs would be the opposite. So let's say that we had x is equal to a -1 and the y value would be equal to 1. Then if x is equal to +1, my y would be -1. And that happens for all x inside the domain. When we have the graph is going to be symmetric to the origin. So it's going to be on the y is equal to x line. Postscript, when we have f of x is equal to 0, that's both an even and odd functions for all x values within the domain. And also, if all the exponents in the polynomial are even, then we're dealing with an even function. If all the exponents in the polynomial are odd, then we're dealing with an odd function. And if we have mixed, both even and odd, then they are neither even nor odd. All right, let's begin with example number 1. Decide if the function is even or odd. So if we start in this corner over here, we have r of x is equal to whatever this function is. It's absolutely an absolute value function. Whatever happens with the x on this side, the same output should be happening when x is equal to that on the opposite side of the y-axis. So that means that there's symmetry about the y-axis. Therefore, this would be an even function. For s of x, we look at, again, our graph. Remember, we have f of -x is the same thing as negative f of x. So what does that mean practically? We have x is equal to +1 and we have x is equal to -1. So at x is -1, I'm down here at, let's say y is equal to -1. And then when x is at +1, my y value is up here at y equals 1. So the output for when x is negative is going to be the opposite of whatever the output is when x is equal to a positive. So this would be symmetric about the origin again. So that means that that's going to be an odd function. For our g of x, we're dealing with 3x squared. All of the exponents in this equation is going to be even. So we're dealing with an even function over here. And then for h of x, we have -6x to the 5th plus 5x to the 3rd. Both of our exponents are odd, so we're dealing with an odd function. And that's it. For example number 2, again, we're going to be deciding if the function is even or odd. So we have our r of x again. We're dealing with another absolute value equation. In this case, we are shifted over to the right by 1. And again, we're symmetric with the y-axis. Even though it's not on the y-axis, we're still symmetric to it. So that means we have an even function. In our s of x, we have a cubic function. And if we look at what we're doing here, let's say that we're dealing with x again at -1 and at x is equal to 1. It looks like the y values are opposite again. This would be probably something close to a positive 0.5 and this being a negative 0.5 is equal to y. So again, we're going to be symmetric about the origin. So that gives me an odd function. Our g of x is going to be -4x to the 5th plus 3x squared. We have an odd and then we also have an even. So that means that we're dealing with neither. And then for our h of x, we have -6x to the 5th plus 3x to the 3rd. Both of those are odd, so we're dealing with an odd function. And that's it for our example number 2. All right, we're at that point. So here's a problem for you to try. There will be a link to the solution in the description. Please like, share, and subscribe for more tutorials. Thanks for taking the time to invest in yourself, making a weakness a strength. Ashe.